triangle congruence. So at the end of this video, you will be able to illustrate the SSS, the SAS, the ASA congruence postulate, and AAS theorem. And also, you will be able to prove two triangles are congruent. Let's define some terms. A definition is a statement of the meaning of a word, term, and phrase which makes use of previously defined term. A postulate is a statement which is accepted as true without proof. A theorem is any statement that can be proved true. So we can use definition postulates a theorem in proving two triangles, but take note that we can only use theorem once it has been proven. So it can be used as a statement or as a reason in the proofs of other theorems. A corollary to a theorem is a theorem that follows easily from a previously proven theorem. So we can use definition, postulate, theorem, corollary, properties in order for us to prove that the two triangles are congruent. So let's have first a review. In a triangle, when the vertices of two angles are the endpoints of the segment is said to be the included side of the two angles. So the included side of angle A and angle B is, so let's identify first the vertex or the vertices of two angles. So angle A, the vertex is of course point A, and angle B, the vertex is point B. So the endpoints of the two segments, AB, is said to be the included side of angle A and angle B. In a triangle, when the sides of an angle are the two sides of a triangle, then the angle is said to be the included angle of the two sides. So, the included angle of segment AC, this is segment AC, and this is segment BC, is angle C. So, as you can see, to simply identify the included angle, the common endpoint of the two segments is point C. Therefore, the included angle is angle C. So we have tests for triangle congruence. Again, in order for us to determine that the triangle are congruent, they should be same size and same shape. So when we say same size in a triangle, the corresponding parts of the triangle should be congruent. So we are dealing with the sides and angles. For the test of triangle, we only need three parts in order for us to prove that the triangle are congruent, or the triangles are congruent. One is the SSS postulate. So we need three sides in order for us to determine that the two triangles are congruent. So if three sides of one triangle are congruent to the corresponding three sides of another triangle, then the two triangles are congruent. So as you can see on the given figure, the segment of one triangle has the same markings with the other triangle. So three sides are congruent, therefore we can say that the two triangles are congruent. Another postulate, we have the SAS postulate. So if two sides and the included angle of one triangle are congruent to the corresponding two sides, and the included angle of another triangle, then the two triangles are congruent. So based on the given figure, so we have two sides congruent and the included angle are also congruent. Therefore, we have two triangles congruent by the SAS postulate. ASA postulate. So we have angle, side, angle. So if two angles and the included side of one triangle are congruent to the corresponding two angles and the included angle or the included side of another triangle, then the two triangles are congruent. So here is the illustration for the ASA postulate. So we have two angles and the included side congruent to the two angles and the included side of another triangle. Therefore, they are congruent using ASA postulate. Last one, we have the AAS or the SAA theorem. So we have the angle-angle side or side-angle-angle theorem. So if two angles and non-included side of one triangle are congruent to the corresponding two angles and non-included side of another triangle, then the two triangles are congruent. So this is the illustration for the SAA theorem. So we have two angles and non-included side congruent to the two angles and non-included side of another triangle. So state if the two triangles are congruent. If they are, state how you know. So based on the illustration, we have one angle or two angles and included side. In the other triangle, we have two angles and the included side. So therefore, these two triangles are congruent using the ASA postulate. So we have two angles and the included side. Next, based on the given illustration, the three sides of one triangle are congruent to the three sides of another triangle. Therefore, the two triangles are congruent using the SSS postulate. Next, as you can see, we only have two markings. We have one on the given angle and one side. In order for us to determine that the two triangles are congruent, we need at least three parts of the triangle. So therefore, we cannot determine that two triangles are congruent. So not enough information to tell us that the two triangles are congruent. Another example, so we have two sides and included angle congruent to the two sides and an included angle of another triangle. Therefore, these two triangles are congruent using the side-angle-side postulate or the SAS postulate. We have the sides and included angle. Next, state if two triangles are congruent. If they are, state how you know. In the first triangle, we have compared to the other triangle. So we have two sides congruent. In first triangle, we have the included angle. In the second triangle, we have the non-included angle. So they do not have the same because this is included angle and this is not. So therefore, the two triangles are not congruent. So based on the illustration, again, can you identify if the two triangles are congruent and determine the postulate? By the illustration, as you can see, we have three sides congruent in the three sides of another triangle. Therefore, the two triangles are congruent using the SSS postulate. Next, we have two congruent angles congruent to another triangle and non-included side. Therefore, the two triangles are congruent using the SAA Theorem.